once you've zeroed out your polynomial equation, you factor it, and I chose an easy one. It's x minus 5 squared, isn't it? And the only reason I'm writing it twice, I'm not doing it because it means anything special, just doing it. And the solution is whatever causes a 0 here, right? And it's the same. X is equal to 5, oh my, and it is a double root. Why? Because it satisfies 2, okay? 5 is the 0, okay? We have just found that 5 is the 0, okay? Which leads me to example 4. If 5 is the 0, that means 5 plugged in for x will cause this equation to be a 0. Or up here, if I plug it in, 5 squared, which is 25, added to 25, indeed is 10 times 5. So it creates a true statement here in all locations, and it's called the 0. 5 is the 0 for this because it creates a 0 here, okay? Example 4 looks all scary and crazy, but we're gonna go through it. I want to at least show it to you. You're not going to do a whole lot with it, but I want to at least show it to you. Find the zeros of, and what they want us to find the zeros of, I'm going to do, you know what, I think I'm just going to do the one they've given us because my examples are nuts. I'm just going to do the one they gave us. F of x equals x minus 4 cubed minus 4 3x minus 16. To find the zeros, you replace this with 0. That's it. To find the zeros, you replace f of x with 0. And then simplify all of this, refactor it, and do what we've done so far. Okay? Which is truly quite a pain. It takes a lot of work. So to find the zeros of something big and ugly like this, replace f of x with 0. Simplify this over here, because you notice we've got whatever this is minus whatever this is. And in order to find the zeros, you can't just say, well, x minus 4 equals 0 and 3x minus 16 equals 0. That's not necessarily true because there's this component combining this with this. So first, replace f of x with 0. Second, multiply this all out, simplify it. And third, then factor and go back to the process we've learned. Okay? So x minus 4 times 3. Well, first, we'll do x minus 4 squared, which is x squared minus 8x plus 16. Am I right? But we need to cube it, so we got to multiply by itself one more time. Okay, this simplification will be easy. This is the bumpy part. So, go ahead. What's your question?
It's 16.
It's 16. Sorry. Thank you. Yep. Okay, let's do all of this times that, which is going to be x cubed minus 8x squared plus 16x. I'm done with this, which means I'm done here. Move in one position. So now I've got negative 4x squared, and you know what, I probably shouldn't even put that there. That'll somehow screw me up, so I'm just going to do that. Positive 32x, shoot, what is that, negative 64? Negative 64. Should have given myself a little more room. And they've actually done all this math for us, but I just wanted you to see it. X cubed minus 12x squared plus 48x minus 64 is this. Okay? So 0 equals x cubed, all of that, minus 12x squared plus 48x minus 64. I don't know why that's not turned off. Sorry about that. Usually it's turned off. Then we're going to do the negative 4 by the two components in the parentheses, which makes us negative 12x, and what is that, a positive 64? How convenient. Yes.
Where did you get the x squared minus 8x plus 64?
I squared it. You know how this said cube it? Well, in order to cube it, x minus 4 times x minus 4, I just squared it first, and then I multiplied it by x minus 4. Good question. Yes, simplify. Cancel each other out, right? So 0 is equal to, all right, so we've got x cubed combined with nothing, x squareds combined with nothing, but the 48 and the negative 12 become what, 36x? Okay. Now we go back to, so we've equated it with 0, we multiplied it all out, and then collected all our like terms, because this is most simplest that. Okay? This is the simplified version. Now we need to factor. We're going to factor. Pull out your x, and you end up with x squared minus 12x plus 36. Is there anything else, greatest common factor, that we can pull out? Do any patterns fit? Yes. What pattern is it?
Square.
It is a perfect square. Good. X minus 6 squared. How do I know? Because this has a square root of x. This has a square root of 6. And 6 times x doubled will give me negative 12x as long as 6 is negative. Therefore, this is the correct factor. Solve. So solve x equals 0 and solve x minus 6 equals 0. You don't have to solve it twice, even though it's squared. You know that your solution set is going to be 0 and 6, which is a double root. Oops. 0 and 6, which is a double root. Find the zeros. All right? So if they ever say find the zeros, just replace f of whatever and find the zeros. I would like to do one more of these with you, if that's okay. No, Mrs. Myers, it's not okay. All right. Let's do this one. I'm going to turn the page, okay? And this will be the last thing we do. This is actually right out of your textbook. It's number 47. And it says find the zeros and identify all multiples. So in other words, instead of saying double 0, you say double root. We've said double root. Well, we're going to say double 0 if we have any. F of z equals 9z to the 4th minus 12z cubed, lost my place, plus 4z squared. Oh. Okay. Any greatest common factor action going on? And we can't simplify it at this point. It's not like it's that big thing what we had. This is already nice and pretty. But z squared, I would say, could come out of all of these, right? Which leaves me 9z squared minus 12z plus 4. Am I right? Any other greatest common factor action that we might have screwed up? I don't think so. What do you think the factor pattern is? Oh, I forgot to write is 0. Is that a perfect square? Is that a perfect square? If I take 3z, multiply it by 2, and double it, can I end up with the negative 12? Think about it. If I take 3z, multiply it by 2, what do I get? If I double it, can I get a negative 12? How? Negative. That means it's a perfect square, which means the factor is z squared. So we'll solve z squared. Z's got to equal 0. And technically, since it's z squared equals 0, that means this is a double root, or in this case, a double 0, because 0 times something equals 0, or 1 times 0 can equal 0. Because I basically just solved for a square. And then I've got 3z minus 2 has to be equal 0. So z is going to be what, 2/3? Add 2 and divide by 3. That also is a double. Why? Because it's a square. Double 0. Okay. Now, I didn't even have you guys going that far today. I wanted you guys to get introduced to it. But I do want to work number 33 with you, okay, just so that you can see it. And then I'll let you guys get started. 33. 33 is kind of going back without the f of z, f of whatever. 33 says solve and identify all double roots. U minus 2 cubed minus 3u plus 8 is equal to 0. Okay, so this is related to what we learned yesterday, but what they failed to tell you in the lesson is in order to do this, you have to simplify first, factor the new simplified version, and then solve for 0. Just like this whole thing. Okay, how we had to replace that with f of z, and then we simplified it and factored it. We've got to do the same thing with this. So in order to do that, let's square this and then multiply it by itself one more time, because this technically means u minus 2 times u minus 2 times u minus 2. So u minus 2 squared is u squared minus 4u plus 4. A squared, double the product of a and b because I memorized the factor patterns, and then b squared. But we've got to multiply it by itself one more time because it's actually being cubed. And you end up with u cubed minus 4u squared plus 4u. We're done with this slot because we're done with this. Now we're going to do everything in the top by the negative 2. Negative 2u squared plus 8u minus 8. Does that look good, everybody? Okay. So the sum of these two pieces is what the product of u minus 2 cubed is, which is u squared minus 6u cubed minus 6u squared plus 12u minus 8, okay? This times this gave us u cubed, this times this, negative 4, u squared, this times this, that. We're done here, moving in, gave us that, which is how we came up with the following. U cubed minus 6u squared added to 12u minus 8, which needs to be combined with the 3u and the positive 8. By combining it with the 3u and the positive 8, or the negative 3u and the positive 8, we'll then be able to factor it.
Cheerleaders to the gym at this time, thank you.
There's no squares that can be combined, but there's u's. 12 and negative 3 is how many u's? Guys, come on. 12 and negative 3. Yep. And we can combine our numbers, which what? They cancel. Beautiful. Okay. Greatest common factor. Is there anything we can pull out? U is right. U squared minus 6u plus 9. Okay. Any patterns that seem to match? It is a square. And it's a negative 3. How do I know that? Because if the middle term is a negative product of double A and B, then this has to be negative. Yep. U equals 0. U minus 3 equals 0 for a double root of 3. There's your answers. Okay, that is number 33. Which will help you with number 34. Okay, my friends.